Hello, everyone. Today is Tuesday, November 4th. This is week one, day two of India evening and weekend platoon. Today's lesson will be Git Fundamentals. But before we get to that, yesterday was your first day. You met Jordan, our lead. You met Tiffany, I believe. Not sure if Umar chimed in. That will be your team of instructors for this cohort. Big advantage that you got. Well, I'll start with the not so good thing. I'm sure I probably mentioned this to a couple of you before if you came to any of the technical check-ins before, but I think the evening and weekend program tends to be harder than the full-time immersive program. And the only reason that I believe that to be true is because you're juggling a lot of different things in addition to learning how to code. Where if you went to the full-time immersive program, you would just be focusing on coding, 40, 50, 60 hours a week. Does that make sense? Right. So that's why I believe this program is a little bit harder because you're juggling all your day-to-day responsibility and then somehow finding energy to learn how to code, which is not the easiest thing in the world, especially if you come from a non-technical background, which most of us do. So I'll say that. The good thing is all your instructors are devs. So I think you have a slight edge in terms of instruction. And this video is being recorded, so full-time knows that. You have real devs that are working in the field right now that are running into, real problems at work that they can share. And you'll notice that as your instructors are teaching, they'll say, hey, they'll give a very esoteric or niche example of how something happens, right? You would not know that unless you were actually actively working in the field today. Does that make sense? Okay, let me give you one of those examples right now. Today's class is about Git fundamentals. When you get to your job, depending on where you go, they're just going to assume that you know Git and GitHub or GitLab or Azure or Code Commit or whatever online repository your work uses. Does that make sense? Maybe some of you guys go work for like a bank or even like one of the big four automotive companies like GM or Ford. Some of their systems are super antiquated, right? They'll use some kind of like online repo that you've never heard of that's proprietary to them, right? The ideas are the same, right? This idea of branches and versions and merging and all of that and fixing merge conflicts, all of that's the same, except you've never heard of the program. Make sense? We have you learn GitHub here because if you learn GitHub, you're going to be able to learn all the other ones. GitLab, Bitbucket, they're all the same. The ideas are the same. The GUIs are slightly different. But if you learn one, you can learn the rest. So when you get to your job, they're going to assume that you already know how to use Git and GitHub or GitLab or whatever that they're using. Not the greatest assumption, especially for new devs, right? And every now and then you'll run into a situation where you're working with like either solution architects or like just like security people, and they'll be like, hey, this needs to get fixed or this doesn't meet, X bar, fix this. And it'll be something really, really small. And you'll be like, hey, you just fix it and just send me the PR. And they'll be like, I don't know how to use Git. And it drives you up a wall, right? Because they're just going to increase your workload. And that stuff periodically happens, especially when people like to talk about working with cross-functional teams. That's kind of one of the pain points of working in these cross-functional teams. Not everybody is a programmer, right? It's like accounting, right? They don't know how to fix anything, but they can tell you when something is wrong, right? So underrated, Git version control. Just very quickly, a very common interview question. What's the difference between Git and GitHub or Git and GitLab?
One is local, one's in the cloud.
That's the main thing you have to remember. One is local, one is in the quote cloud. When someone says cloud, what is a cloud?
Someone else's hardware.
There you go. Someone else's computer. I mean, it could be yours in your closet if you want, but it's just a computer. There's no real cloud, right? It's just a computer somewhere. Typically where people can buy a lot of land cheaply and get electricity, right? Make sense? Cool. Alrighty, so today's lesson, Git fundamentals. Get really good with Git because it will consume your life if you're not good with it, especially when you start running into really big applications and you start making a lot of changes. Can everyone see my screen? Yeah. Okay. And I've used this example before, but I'll go ahead and use it again. You might, the following situation might happen to you, and it's actually quite common. You'll come onto a program or they'll assign you a task, right? And they'll say, okay, have a PR for, X feature or X bug fix, right? And then you'll have it, but then you'll notice there'll be other merge requests, right? So your boss will say something like, hey, go ahead and put your changes on top of Angels or on top of fonts, send it to me, right? But the other person whose changes you're merging as well touch like 50 files, right? So now you're putting your, changes that touch maybe a dozen files on top of someone else's changes and they touch 50 files. And now you have this giant PR you have to send your boss by the end of the day, right? And you can't how to figure out how to merge everything properly, right? Because you all touch the same files, right? So whose work takes precedence? You'll run into that quite frequently. So it's really good to be good at it. And the faster and better you are at Git, the easier those kinds of things will become, right? Because when you kind of calculate how much time like a task is going to take, no one ever like adds extra time because you don't know Git. Does that make sense? Like that's not factored into the equation at all. But us as newbies, myself included, right? Probably one of the hardest things that I had to deal with. I was actually pretty decent at Git early on, but not good enough to be super fast with it. That's it. That's my little rant on being good with Git and GitHub. All right, what is Git? Local version control. That's the only thing you need to remember. GitHub is just an online repository where you can share your code and other people can either clone it, copy it, use it, collaborate with other people across the globe. That's all you need to know. This just kind of talks about the UI. Everyone has the curriculum, right? Right. So I'm not going to go over this word for word, but this is just like a little repo. In a second, this is just a repo I have on my GitHub here. It's got like 2 files. It doesn't have any real code in it, but I'm going to use this as a demonstration here shortly, how you would use this. All right. So this is just a little GUI of GitHub. This just shows you the GUI of GitHub. And then you can go in and look at all the commits. So for example, I'm just going to use this little example because it only has 2 files in it and it's easy. This is just a repo that I have in my own personal GitHub that I call demo, right? And if I wanted to clone this, I would just go here and then I would just clone it. But if I wanted to see the actual commits to this repo, I could just click on commits, right? And this shows that, hey, this was uploaded on September 17, and I can click this and this is added files. And the green just shows, hey, I added something and the changes are here. 2 files changed, 18 changes. I didn't remove anything. It's a brand new repo. I didn't remove anything because there was nothing to remove. And then I just added this file called index.js and then index.py. This is some kind of code in here. I just wrote the string, the words no code. Make sense? If you haven't messed around with GitHub, definitely mess around with it today. Kind of figure out what all the buttons do. Delete repos, create repos, push to them, merge changes, open a PR on your own repo to kind of figure out how all that works. So that's just a little GUI. You can look at commits. You can look at pretty much anything. This is the single commit view that I just showed you, right? The red means, hey, lines were deleted. The green means that lines were added. Git versus GitHub, it's exactly what you just said. It's exactly what this image says, right? Git is just local to your computer, where GitHub is on somebody else's computer, right? That you can pull down from any computer. Make sense? Like if you have your code on a branch locally and you leave your laptop and you go to a friend's house, you don't have access to that code because you left your laptop at home, right? But if you had pushed that code to an online repository, you can get on your friend's computer and clone down that code, right? Super important. All right. Git is just a command line tool. We're going to go ahead and mess with this a little bit. I'll go ahead and pull up a terminal if I can find one. There you go. This is my little terminal, and I'm at root. The Mac always opens at root, but if you own a Mac, you have to. I would always suggest putting your repo just on your desktop, something that you can easily access, regardless if you're on a Mac or Linux or Windows or whatever. So I'm on a Mac, so I'm going to cd into desktop, and here I'm actually just going to make a folder called test, right? And if I lsla, this Linux command, I can tell I have that folder right there that I just created right now, right? I created this folder on November 4th at 5:41 Central. Yes, called test. And then I'm going to just cd into test. Cool. I can check what's in there, right? There's nothing in there. Cool. And I can go ahead and start creating a Git repo, right? I created just a test repo, but you can call it whatever you want. And I'm actually just going to clone this. I'm just going to clone this specific repo, right? I'm going to go here and then just git clone. If I do lsla here, what files are going to be in here?
Index and .js and index Python.
Yeah.
And hidden files.
Yeah, the hidden files, my demo folder, but if I go in there, it's just going to be those two files, right? Cool. That's awesome. I could even open up with this little shortcut. You should have installed it yesterday with the code dot. I open VS Code. Cool. I have it here. Awesome. If I open a terminal window here and here, what's the difference between these two terminals? This one and this one.
Nothing.
Why do you say it's nothing?
It seemed like yesterday we kind of synced them. I don't know.
Is there any difference at all?
They're probably different sessions.
You're in
right?
the same working directory.
Well, you guys got it. They're different sessions, right? But they're in the same working directory. That's really, really important. If I do some var, and you can see I already used this example, and I have supercat, right, in my terminal on the right, and I echo, which is just bash for a print statement. Oh, my bindings are not working. Oh, need to figure that out. Doesn't matter. And I echo some var, which is really just printing here. What's going to be printed on my terminal?
Supercat.
Yeah, supercat. But if I do it on this terminal and I echo this some var, am I going to get supercat here?
No.
No.
No, there's nothing in there, right? This variable only exists, right, in this terminal. And this terminal is ephemeral. So the minute that I close it, it's gone forever. I would have to reset that variable. Right, it doesn't exist.
That doesn't apply if you clear it, though. Or if you clear it, do you lose the variable?
No. Clear is just what?
Making space on your screen.
Yeah, that's all it is, right? I would have to close it out.
Okay.
Right. All right. So I'm in the same working directory. The answer is, for all intended purposes, is no. You can do the exact same thing. This is just a built-in session if you want to see your code in your terminal all on one screen, which is super handy. But there really is no difference if it's in the same working directory. I think I've probably taught some of you this. What are the two tenets of Linux? Does anyone remember? If you went to any of the technical check-ins, you should know that.
Files and directories?
No, not quite. What should you always know when working in the terminal?
Absolute pass.
Where you are.
Where you are is one of them, and who you are. Right. So any time you're working in here in your terminal, you're typing in cool code here, Linux commands, whatever. Right. Always know those two things. Who are you and where you are? Who are you is kind of what permissions you have, and where you are is where in the file tree you are. Make sense?
Mm-hmm.
Inevitably, probably a handful of you will start trying to execute like running scripts, or you'll try to log into a Docker container, and then you'll call someone for help, and then we'll jump into your breakout room, and then you'll be running commands, and you're saying, hey, this isn't starting. Why isn't this working? And someone will say, well, where are you right now? And you'll be in the wrong directory. That tells me you don't know where you are because you're trying to execute a file outside of the proper directory. Happens all the time. Happens with Git all the time too, right? You'll attempt to save something, right? Or push something in the wrong directory. And then you'll have like nested init files. And then you'll have Git tracking on multiple layers of your directories, which is going to mess everything up. Does that make sense?
Yep.
Okay, keep that in mind. If that didn't make a whole lot of sense right now, that's okay. We're going to work through it. But just understand this. Go ahead.
Are there any Git extensions that will flag that for you? Like that will notice? I mean, maybe I guess it's arbitrary to the computer.
I have no idea, but don't use them even if they exist.
Okay.
There's I think this is a Git graph. I don't even know if I even have it in here. I think this is it, right?
Yeah, that's
Oh, yeah, Git graph. There's, I don't even know if I even have it. Yeah, that's a good question, though. They don't have the I don't think I have the high speed one installed.
Like
It
flag
does.
it like a linter, like, hey, this is being tracked at multiple levels.
Yeah.
Are you sure?
That's a really good question. No, just keep track of it. I'm sure that those things probably exist. I don't know. I've never used them. But it's the same thing with Git graph here. I would stay away from any of that kind of high speed stuff right now until you kind of know what you're doing. Right? You should be able to look. You should be able to look at a path and know if you're in the right place or not. Does that make sense?
Yeah.
Like if you need a tool to help you do that, you are gone. Does that make sense? Right.
Yeah.
I use Git graph as an example because you'll see a lot of people with Git graph and they'll have like really, I think even GitHub and all of them have like GUIs where you don't have to do like a git add, git commit, git init, right? It all does it for you and it's all buttons. Don't use that for right now. Right. Eventually, if your work has that stuff or they let you use it or whatever is built into your work laptop, feel free to use it. But right now, it's actually really important that you kind of go through all the commands and kind of understand what those commands are doing. Right. Like when I do LA, do you know what LA is? Like intuitively, do you know what it's going to do? You don't have to answer that question. It doesn't really matter. Right. When you do git add dot, do you know what dot is? Right. If you added hyphen F, do you know what that does? Right? Like it's really important that you understand that right now before you start using a lot of these like high-speed tools with GUIs because that abstracts a lot of what's happening in the background. And right now the fundamentals are really important for you.
Mm-hmm.
Make sense?
Yeah.
All righty. So there you go. Cool. All right. So I am here and close that out. So I am here. I'm on main, and this is a lesson it was a Git lesson we're working through. Right, CD into you can call it my first repo, you can call it demo, you can call it test, whatever you want. Right, this will show you the files. What does git init do?
It initializes it as a GitHub repo.
Yeah. It tells you, hey, this is a GitHub repo. And actually, I screwed up. I already initialized this folder. You can tell because you can see the main on there. But we're just going to pretend that it was brand new, which is totally fine. Git init tells your terminal, hey, start tracking all of my changes right now. Right? And this is already initialized. So if I do some file here, .js, right? And I do some code, or sorry, my bindings are not working. I don't know what's going on. All right, cool. So I added some code. I added a new file called somefile.js, right? If I hit clear in the terminal, what are you going to see in my terminal? I'm going to type in clear and hit enter right here. What are you going to see in my terminal?
It should clear up the screen.
but it's already clear. What's going to happen to that path right there?
Oh no, try doing that.
Nothing.
Something's going to happen.
Are you going to change directories?
No, I'm just going to press clear here. I'm going to hit enter. What's going to happen to my path right? What happened?
Are you writing to that?
No, I'm not writing. I just hit clear, and then this showed up. What is this?
So like it's asking how many, how many. It's definitely asking a question. Oh yeah.
All right, how about this? Paying very close attention to that terminal is going to try to help you out. If I do this, and I do clear, what happened?
Oh, okay. It's like a backspace.
Is
Or,
it showing one change? Like
Yeah.
it's tracking one change?
That's it, right? Your IDE is going to try to help you, right? So when I had some file .js, and I had whatever, right? And I went to clear the terminal. It just all of a sudden tracking that change, right? And actually, if I go here, it's going to show me, hey, you shows a different file, and I just added to that. That change is new, and it's saying, hey, there's one uncommitted change. That's what that means. The change is really subtle, but I need you to really pay it. That's all Git is, right? Now it's tracking that change, right? I don't have to commit it, right? I can get rid of it, right? In which case your ID would try to help you out. And then like, for example, that's just one change. I could, some other file. If I clear it again, it's going to track two changes, right? I just added two files. And I realize that .com is not a real file extension, but you get the idea.
So do you only get the update to the number of changes that it's tracking on clear, or is it any command within the terminal?
Any command that runs in a terminal, it like refreshes the terminal, right? This is going to catch it right away, this right here, but this is kind of like a nice to have on VS Code.
And those staged changes are counted in the terminal until they're committed, or until you end, like you quit the terminal?
They will always appear now that I'm tracking this specific branch, right? Like that's a great question though. If I delete this terminal, right, and I go back to it, it's still being tracked.
Okay.
Good question. I don't think anyone's ever asked me that, but yeah. Right, so now I have two files that are changed. This isn't real code, but it doesn't really matter. I'm just showing you that, hey, this is tracking these changes locally, right? Okay, cool. So Git init just says, hey, start tracking from now, right? Git status, this is a good one. Git status shows you in red unstaged changes, right? Changes that have not been saved in any way. That's why they're red, right? But if I wanted to stage them, git add, what does the dot mean here?
All.
All. Keep that in mind. All, dot in Linux means all, right? Whenever you get to like CloudFormation templates or a Terraform star, a star will also mean all, like a star. This one, that. Something to keep in mind. All right, so if I git add here, right, it shows +2. And if I do a git status now, what is it? What's the difference here?
They're staged?
Yeah, they're staged. That's why they're green. Now they're not committed, but they're staged. Now they're saved. Okay, cool. So now they're staged. And then I can do what now?
Oh, I noticed too, it changed on the prompt command. It went from a question mark and then tracking to, and then a plus tracking to. So that means that they're unstaged versus staged.
Yep, that's what that means.
Very cool. Yeah.
Right. So git add git status. I can then do a message, added whatever new file or added to code, doesn't matter, right? Now it says, now it tracks your files. Now they have actually been saved, right? So now if I wanted to push them up, right, I could just go git push. And if I go up here to this, if I hit refresh on this remote repo, what should you see here?
Those files.
There they are. There you go. All right. So before going into git status, this tells you to go on branch main. I'm already on branch main, but I can also check what branches, how many branches I have, right? Git branch. How many branches do I have?
One.
One. When they talk about branches, they really just mean different versions of what?
Your
whole repo.
Yeah, your code, right? Like here, on main, I only have one version of my code, right? But if I wanted, right, to have a different version, let's say you're working on a fix or something, right? This is a command. This is kind of more of a slightly advanced command, but is a command I use a lot. I'll git switch and I'll give it another branch, like let's say feature fix, right? So what this did is actually created a new branch off of main, right? So right now, feature fix and main are actually identical branches because I made a copy of main and I just called it feature fix. So now if I do git branch, I have two branches, right? So I'm on feature fix, which the index file has no code, bears are going to be 0 and 17. That's what's on that file, the index.js file on feature fix. If I check out main, what's on index.js on main? Yeah, bears are going 0 and 17, right? It's the same. They're identical. Make sense? Now I can check back out feature fixed. Sorry. I need to fix that. Yeah, it's not working. Okay. So I'm on feature fix here, right? And it's identical code. But if I went in there, right, and I read right, and I change it, right, and I hit clear here, what should you see in this line?
That
The
question
one with the
mark.
question mark?
Yeah, one with a question mark because I have an uncommitted change, right? And you can see it right here.
Is the so in the in the example it said git checkout -b, but you used git switch.
Yeah. Git checkout B is a different way. It's like coding, right? There's a million ways to do something,
Okay.
right? Git checkout B is check out a new branch, right? Git switch does the same thing, except it takes uncommitted changes to the new branch. And if there's none, it just duplicates the branch.
So what was your -c flag?
-c flag, I actually don't know what that means. Git switch, or I forgot. Someone Google it. Let me know. I forgot what it was.
I'm looking.
I can show you again. I probably should have just used git checkout, but I'm so used to using my switch. But let me get back to that. All right. So what do you notice here? This is your change, right? Now I have one committed change. You remember that? All right. And someone just asked me, hey, why did you use switch instead of -b? This is why. You see my uncommitted change? What did you notice?
It's still tracking the uncommitted change.
It brought it over to the new branch, right? So now, stay with me. This is going to get a little confusing. Git add dot git commit. I'm going to have to fix that during the break. commit bears win. So now bears win is different, right? The index has bears Super Bowl champs on bears win. But if I go git branch and I git check out feature fix, what's on index.js for feature fix?
The one with the score.
I never saved that change on that branch. So that's still 0.17, right? But if I do git check out bears win, that version is different because I brought that change and then saved it on the bears win branch, right? So this is going to be bear Super Bowl champs. Use git checkout -b. Let me show you why you would use that. Let me go back to main. Let's go back to our original code. Before I do that, how many different versions of my code do I have?
Yeah, 3 branches.
I have 3. There's 3 different versions of my code, right? I have bears win here, git checkout, feature, fix. I have this version. Notice my VS Code is changing, right? And if I git checkout main, which I don't think I changed the code on index.js for main, so it should be the same, and it is. But I have 3 versions of my code now, right? Yes? All right. There is no changes being tracked here right now, correct? All right. I want to check out a new branch from main. Someone give me the command. I'm going to check out I'm just going to make a different copy. I don't want to mess up main. I'm going to work on something that I think may or may not work, right? Give me the command for making a duplicate of main. Git check out what?
Is it -b?
-b.
I don't know.
And then just call it test branch. Okay, cool. So now test branch is the same as main, right? Yes?
Mm-hmm.
Gotcha. All right. Let's say I was to delete this. On test branch, I'm going to delete these 2. And I hit clear here. How many untracked changes are there going to be?
2.
2. All right, cool. What would happen here if I try to check out a new branch? Let's say I wanted to check out a new branch here. Git checkout b test branch 2. What do you think is going to happen here?
It takes the on-stage changes with it?
Huh?
It takes the on-stage changes with it?
Let's see if it does.
So it clones the current state, or I guess it copies the current state of that branch that you're in. What it looks like it's doing.
It did, right?
So
Just different ways to do the same thing. Typically, I don't want to ever affect the branch that I'm in. That's why I typically switch. But if you want to do checkout, that's perfectly fine.
Can I ask again, why would you want to say clear if we're not, for instance, if we're not configuring currently right now, let's say we're in test branch 2, right where we're at. Usually I'll use clear to kind of clear up the screen. Why would I use clear again if I'm not modifying the code?
Oh, that's just to give you more space of real estate, right? Like
Gotcha.
I keep doing this. I'm kind of at my last line. It's really just a developer thing. If I do clear, it just cleans it up so I have more space to type. That's all it's for. I can continue, right? It would keep up scrolling or whatever that phrase is, right? But that's kind of annoying. It doesn't actually do anything. It just gives me more real estate.
All right, and then whenever we had the terminal cleared already, and there was no it didn't tell us any uncommitted changes, like it's showing right now. Why would I hit clear if I have a clear space already? Because I never, well, it's not like I'm super experienced in it, but like, would I do that on purpose just to, on a clear screen, just to see how many
No,
uncommitted
no, no,
changes I
no,
have?
no.
Okay,
You could just do git status so you would know, or you could literally just look right here.
okay,
I was
gotcha.
just using it as an example.
Okay, cool.
But no, like if I deleted 2 files 2 seconds ago, I don't need to be reminded that I deleted 2 files 2 seconds ago. I was just doing it for you guys to pay attention to. This is trying to help you. Like your
Gotcha.
path is going to try to help you. Your ID, when it
Oh,
underlines things, it's trying to help you. Right? Pay attention to it. Make sense? All right, cool. So git status, difference between staged and unstaged changes, committed changes. This is just an example that you can add files. You can add files. Did everyone catch that command that I just ran? I should have probably said it.
Git restore.
Yeah. If you have uncommitted changes, right? I have like one uncommitted change. I just added line 5, right? You can do git restore if, hey, oh, this is crappy, you haven't committed it. It just clears it. It just removes it. I'll try that again. Again, I don't know where that is in the lesson, but slightly more advanced command, write some other code. And you realize you haven't committed any of this code, you haven't added that. It's being tracked, but you realize it's junk. Git restore all of it, all of the files, just restore back to the last save space, and it gets rid of it instead of having to do it manually. I'm sure you guys probably are all noticing I'm going out of order. Can anyone tell me why I'm going out of order or have a guess?
I would say to make the branches make sense as you're talking. Um, like if I was reading through this right now, I would probably go, all right, I created this branch, cool, whatever. But I think from seeing it, just from my perspective, seeing how you related them to one another makes a lot more sense.
Yeah, that's what I'm trying to do. I'm trying to make this as helpful for you as possible, but also notice that I already know Git, right? It's weird for me to follow a lesson plan on something that I already know intuitively. That's where you need to get to. Does that make sense?
Makes sense.
Like if I need to know how to do something, I know what I'm looking for, right?
Oh,
So go ahead.
oh no, I'll just wait because you're probably gonna get to it. Where I get confused too was the merges. So let's say, for instance, let's say one team was working on that Bears win, another team was doing feature fix, another, you have these different teams working on this one code, and from what I read, that's what it seems like it would be like. How, and then you go to merge them. That's where I kind of started to get confused. Like, okay, hey, this team was like doing one button on Bears win, another team was working on like this window on feature fix. And so I'm used to the old mindset of once you say it, just say the most recent thing. How does it merge? That's where I get confused. Like, how does it take all the stuff that was merged and then just bring it in as one package without overstepping somebody else's um development or product?
Yeah, that's
If that
something you
makes
guys are
sense.
going to work on here independently and in groups here shortly. That's the trick to the whole thing. Everything that we're showing you right now, guys, this is the easy part.
Gotcha.
But the
Yeah.
crux to the Git is really resolving the merge conflicts and like cherry picking and then squashing commits and then merging very divergent branches. Right.
Gotcha.
And when you get to work, and this is a pet peeve of mine, right? When you get to work, you will see not only disparities in coding ability, but disparities in people's ability to understand CI/CD pipelines and Git and how it's supposed to work, right? They will merge things, push it to main, and then you'll realize that once you pull, it breaks all your stuff. And then you have to ping them and say, hey, man, your change broke it. Can you please fix it? Why? They did their merge incorrectly. Happens all the time. It's very upsetting. You don't want to be that person. Yes? All right. So going on with that, I'm going to teach you the way that I kind of do it. I'm going to show you my approach and just follow this for now. And eventually you'll develop your own little way of doing things. Again, it's coding, right? So there's a million different ways to do it. But you should never work on main or master. Whatever your main branch is, you should never be changing it. Git checkout main. If I have main here, you should never be editing main. Now, granted, depending on which company you do, sometimes they do, but then you figure that out when you get that. But for right now, no one should ever touch main, right? The minute that you git pull, right, from main, and it shows, hey, you have the most recent code for everybody that you're working with, right? You should git checkout branch. I always do git switch, but whatever you want, right? And say, hey, feature branch, mine, whatever. And here you work. Why is that? It keeps your main branch clean. And anytime any changes are pushed to your remote branch, you can switch to main, pull the changes, and you always have the most recent changes of your remote repo locally. And they're clean. You haven't messed anything up yet. And sometimes you're going to have to compare what is in the remote repo locally to one of your other local branches, and it makes it easier.
What if, so when you do a git pull on your main branch and you're making sure it's the most updated, you go into test branch and let's say now you want to pull, you want to pull something from the main branch. Would you do the same thing, git pull the main branch in order to get the most latest, or is that very or hardly ever done?
Okay, so you always work on feature branches that are not main, because main has a specific purpose for you locally. This is the way that I'm going to teach you because this is the way that I do it, and this is the cleanest way to do it for right now, right? Main should never be altered. You should always alter feature branches, and you will always be merging feature branches onto main, or feature branches onto other feature branches, and then onto main. Main shouldn't merge into anything. Everything merges onto main.
Oh, okay. That
Now,
makes
there's a
sense.
lot of different ways to do it, but for right now, that's what you need to learn.
Okay.
Does everyone understand that?
Yep.
Main never merges into anything. You merge onto main. Keep that in mind for right now. There's a bunch of different takes on it and people do it slightly different, but for right now, that approach will get you into the least amount of trouble.
Okay.
Make sense?
Makes sense.
And you're going to run into this in your group projects. People will be working on different things. And they'll start merging their main branch or editing their main branch and pushing up to it, right? And then start messing everything up. So keep that in mind, right? Never merge onto main. I mean, never edit main. You only merge onto main.
And then let's say that you have, okay, we merge onto to main and we throw our feature branch into main. And then we end up later on down the road, we do a git pull from the repository. And will that mess, is that part of the things you were talking about? Like, we'll talk about that as we go on because
yeah, we'll talk about it in a second.
Okay.
You're going to run into
Gotcha.
some merge conflicts, but yeah, we'll get into it. Let's see how this lesson teaches it.
Gotcha.
Here, I just went over git add, and you always see people do git add dot. That just means all the files, right? But you can add every file individually. That's what this is showing. You can just name the file. And like if I wanted to, for example, if I wanted to add some other file.py, and I didn't want to do a git all, right? I could just git add and then some other file.py. And you can actually stack the files. If I had some other file2.py and some, extra file.py, you could do that too, right? You can add them individually or you can add them all at once. It really just depends what you're trying to do. Make sense? Okay. So that little section was just about adding. And this just, yeah, they're editing the file and then making changes. We talked about untracked files. Untracked files is just when you make a change that's not tracked. Like for example, this one. This one is now tracked, right? But I haven't saved it or anything. And you can tell that here, the ID is going to try to help you out saying, hey, there's a change there. And obviously your path here is going to show $1. We have one track change here. Here you do get status. This is come out red. Why is this going to come out red?
No,
It's on track.
Not committed yet.
Yeah, it's not staged, right? So it's red. But if I wanted to stage it, I would just get added and then it'll be green. And this is what this is showing right here. So let's go ahead and do that actually. This is just, I forgot the name, some other file. I can't even spell. That doesn't matter. Let me just do a get add. If I do get add dot, right, showing that +1, get status. Once again, now it's green. That's being staged. Cool. This shows that, hey, it goes from untracked red to staged green, and then you can push it. Here it just shows you that you can actually remove this. You can unstage it if you want. So you can do that. Here it just shows you the 3 files that are staged. You can do them individually, or you can just do, dot, period. And then you can commit with a message, right? I could just do this one, my first commit, sure. And it'll show you the actual change here. That's how you know you did it right. Right. And then once they're committed, they're committed. Okay, so this is actually kind of a little bit confusing here. This is committed. What does that mean?
It's saved to that branch on your local machine.
Yeah, it's all right. So that's a really important distinction here. It is committed and saved on your local machine. It means it's actually saved here, right? When I do git log here, that's the last commit. That's me right there. It's saved locally. Is it saved in my online repo?
No.
Not yet.
I have to do what?
Push.
I have to git push, and here I'm running into an error where what is true? I haven't taught you that, so this is just asking.
The branch never got published, so it doesn't have anywhere to push it to on the remote repo.
Okay, this is really important here. Look at my branch. It says feature branch, and this is my alias. I don't know why I wrote that, but all right. It's saying, just again, read the error message, right? It's going to try to help you out. It's saying, hey, this branch doesn't exist upstream, because what's the only branch that exists upstream?
Oh, main branch.
Main. So I have to set this branch, and you can just literally copy and paste it. What I'm saying is, hey, track this branch too. Now, once I push it, now this branch exists on my online repo. Right? So if I clear here and I refresh here, I mean, it showed it right there. I didn't have to do that, right? But now, look at that. It exists now. Now this branch exists here. So if I go git branch, git checkout, feature fix, If I try to push this branch, what's going to happen? This branch right here that I have locally, feature fix, what's going to happen?
We haven't committed it on the local.
Haven't committed it on the online repo. It's available locally. I'm looking at it.
Gotcha. Okay.
So I'm going to run into the same error, right? I'm going to run into the same exact error that I did before because that branch doesn't exist. That version of my code does not exist on the remote repo. It's one thing to exist locally. It's a completely different thing to exist on the remote repository. Does that make sense? So this is where it starts to get kind of a little messy, right? Because locally you can have a lot of different versions, and then remote you can have a lot of different versions, right? Now, locally, If I make changes locally, they're just local until I push them up, right? And if other team members make changes to the online repo, and I have not brought those changes to my machine locally, then the online repo differs from my repo, right? Just kind of try to wrap your mind around that, right? It's local version control and also remote version control. Alrighty, this just goes over Git status. If you're ever curious what exactly you have staged or what you have committed, this command I typed in earlier. Git log just shows you your Git history. Git log. These are all my commits, all the snapshots of my code, right? This is the first one that I made on September 17th, added new files, and then I wrote this commit message called bear suck on the 17th. And then this is my new one on feature fix here today. It says, hey, added new core code, right? Git log will show you just the commit history locally. And if you wanted to see it on the online repo, you could just go here, go to commits, and these are all the changes, right? Per branch, right? Because you're going to notice that the main branch only has these commits, but notice that the commits are different on the different versions of the branches, right? And this one has 4, the other one has 3. And then you can go in there and look closely at them if you want. All right, this one just added 1. Looks like I added 1 file, right? Just added 2 files, some file and some other file. It's just a nice GUI. It allows you to kind of visualize your changes. Cool.
I have a quick question. If you're creating a new branch, like you're working on main and then you switch over to a new branch to just work on some feature or experiment with something, when you're done with said experiment, should you like preserve that branch for this? Like generally best practices, should you preserve it for the sake of having a history to refer to, or is it best practice to go and get rid of the branch after you've done what you thought you were trying to do?
I typically hold on to them. I
Okay,
typically hold
forever?
on to them, not forever, until it gets annoying. Sometimes at the one point you have like 30 branches, then you can start deleting some, like the oldest ones.
Okay.
Yeah. But again, you ask 10 different people, you probably get 10 different answers. But typically, you want to hold on to them for a little bit because sometimes weird things happen, right? Like you introduce a bug or someone deleted or merged something that they shouldn't have merged on top of one of your branches, and you kind of want to look at the original, even though they have a copy of it on the remote repo. Sometimes you want to just fix it locally.
Okay.
Oh, actually, that leads me to kind of bring this up. Let's put some GUIs, right? Some online repos will allow you to make changes using the GUI on the internet. Refrain from doing that. Get really good at managing those changes locally and being able to resolve those conflicts locally. Why do I say that? When people start using the GUI and overly relying on it, right, they forget how to do it locally. And when you make a bunch of changes on the GUI, on your online repo, what happens to all your local versions?
They're no longer current.
Yeah, they're way different, right? And when they're way, way different, you're ultimately going to have to resolve those conflicts locally anyway. So just bring them down, resolve all conflicts locally, then push back up.
Is there, if for some reason like you have to make changes in your online repository, is there a way to push those back downstream?
Yes, but I don't recommend you use the GUI for that. Just pull it back down and then re-push it.
Oh, okay.
Yeah. Cool. This is what I just showed you, right? Just the commit history using Git log. You can continue making changes, right? We talked about branching. Branching is just different versions of your code, right? I have a bunch now, right? I have six versions of my code, right? But I have main, which I'm not going to touch, and then a bunch of different features where I wrote different things. Cool. When people talk branches, it's just versions. I think they just got the name right because it kind of looks like a tree, right? It's a version of a code, but you can always branch off of it and continue branching off of it almost indefinitely. We already did this. This is how you check out a new branch. We haven't talked about deleting. I don't know if it's in here, but I'm going to do it now. When you get done with one of the branches or you don't need it anymore, it's git branch, capital D. And then if I want to delete test branch 2, right? It says deleted test branch 2, then you can go git branch, and there, you have one less branch. Yes? These are known as flags. Anytime you see like a little hyphen in the letter, right? It's saying specifically, hey, do this or run this command, which the capital D is short for delete, right? This is just going through making different branches. This is a visual. I don't know if this is helpful, but imagine you have this like version of your code and you branch off of it, right? It will get this little ID number, right? A commit number, and that's a different version. And then the commit history will start there. Like that new branch's commit history will start there. I know that didn't really make sense, so let's see if we could try to make a little bit more sense out of that, right? If I git check out test branch, and I do git log, how does this git log differ from the other branches?
Those commit hashes will be different, right?
Commit hashes will be different, and some of the commits will be different as well, right? Because if a different version got extra code or deleted extra code, it's going to have an extra commit, right? And if there was only like 5 changes on one branch, but 100 changes on the other is going to have 100 commit hashes and changes, right? So when you make that new branch, that's when the new branch's commit history starts, right? It's a little bit more nuanced than that, but for right now, that's all you need to know, right? Because you can kind of get into, I don't think this lesson gets into it, but you can kind of get into like squashing commits, like erasing commits and like forcing, like rewriting the history more or less. Typically, you don't want to do that, but sometimes you do. Does that make sense?
Mhm.
Yeah.
I have another small question.
Yeah.
And I don't want to jinx this, but say you make some rookie mistake and you delete the wrong branch. Is that's final? Like, is there no going like to the opposite repository and then trying to like go to an older backed up version and then trying to undo what you just did? Like, is a delete a catastrophic change?
Yes. Delete is catastrophic, but if you had already pushed it up to your remote repo, you just bring it back down, right? You just fetch it.
So is that one of the advantages of working in your local repo?
That's advantages of just having a remote repo and a local, right? And having them more or less in sync most of the time. Right?
Okay.
Because if something happens, it's still there. Like, for example, let's say you work in a really awesome fix, right? But it was like, 10,000 lines of code, but you never pushed up that branch to your remote repo and your house catches on fire and it destroys your work laptop. Those 10,000 lines are gone.
So when you were saying earlier, you had mentioned that like it's really common, like in the real world, for like, I don't know, say your PM to be like, oh, just roll those into one big pull request. I'm probably oversimplifying this, but like, wouldn't a lot of very small pull requests be only advantageous? Like just to avoid merge conflicts?
Dude, it depends on your company. This is a really good that's actually a really good question. It depends on your company. When I worked at DRW, the specific team that I was in, all small commits. All small commits. That's what they were about. Then I changed companies and they want one commit when the Jira ticket is finished. That's it. That's the only thing that they care about.
Like the PMs want one big commit, so
It
it's easier for
just
them to track?
depends. it just depends the company and it depends the team. It depends what you're doing, right? For example, like I was on a specific project where the Jira ticket was the name of the feature of the branch name when it was merged. So Jira was locked in with GitLab and everything was interconnected. So it would like the minute it was merged, it would move the Jira ticket over to done, right? And you only had one commit because you only had one shot at it. And sometimes you'd have like 50 commits. That's fine. They wanted you to squash them, list it. You had an SOP how to list the message and the commit, and then that's how they handled it, which is completely different than when I worked at DRW on that specific team. But those are just two teams. It just depends on the company,
Okay.
right? Alrighty, some things. This is just talking about how when you branch off to my feature, right, all the commit history is going to start off of that commit, right? When you kind of branched off of it. Checking out, we've already gone through. You can check out any branch that you have. Git branch, git checkout main, git checkout, Barry's plan, right? Git branch, git checkout, test branch. Look at index.js file. When I check out git checkout test branch, index.js changes. Why does it change?
Because it's a different version.
That's it. That's the only thing I want you to keep in mind. It's a different version. Of course, it's going to change. If that file is different, then it's going to change to match. All right. So this is slightly more complicated part. Actually, I kind of been talking for a long time. I'm going to pause here. Let's take like a 15-minute break. We'll be back at 6:47, and then we'll continue with this, and then we'll do breakout rooms. Sorry, this is kind of a longer lesson. I screwed that up.
Can't hear you if you're talking.
Hello?
Yep, heard somebody.
All right. What is going on? Give me a second, guys.
I just started coming through.
Okay. Can you see my screen?
Yes.
Okay, perfect. All righty. Continuing. We were here. Oh, we're at merging. So in a real project, the feature branch would likely have more than one commit, right? Maybe several hundred. Like I was telling you, sometimes different branches, especially feature branches, will be much smaller, obviously. And you have to merge one branch to another, right? So git merge is the command here. So let's try it here. Let's try it. Let's check out test branch. No, let's check out a branch. Let's check out feature fix. Let's check something that's a lot different. Oh, bear with pen maybe. Okay, cool. Let's merge bears win into main. How would I do that?
Git merge bears hyphen win.
From where?
Origin?
Which is what branch?
In the main branch.
So I have to go where?
Into the main branch.
I have to git checkout main because main is the one receiving all the changes, right? Super important. Again, 2 tenets of Linux. Where are you? I need to be in main. Main is receiving the changes from bears win. Git merge bears win. What do I expect when I hit enter here?
Are you going to
The
get
file
yelled
will
at for not
change.
having a PR?
Yeah, well, besides that, technically, I told you, hey, don't do this, but this is just for the sake of example here.
The
When I
file
hit,
contents to change.
it's gonna try to change, but something weird's gonna happen here. Okay, pay very close attention to this. I'm on main, right? Look at index.js.
You didn't never committed those changes.
No, they're all committed. But you notice that there are 2 different versions on index.js, right? One of them says bears are going to be 0 to 17. This one says Super Bowl champs. All right, so if I go check out main and I do git merge bears win, and I hit enter here, what's going to happen?
It's gonna update all the information you have on.
It can't do that. I am going to merge bears win into main, but I know at the very least different code exists on index.js on both of those versions. So when I try to merge it, what's going to happen?
Is that going to be the merge conflict?
Yeah, it's going to be a merge conflict. The computer is not smart enough to understand which one is right. Right? Let's try it. Oh, I misspelled bears. Too many R's. What happened here?
Looks like it says 1 insertion, 2 deletions. So it within the main. So just by reading this, it inserted whatever the difference was from the bears into main.
It
So
just
who won?
overwrote it.
Yeah, who won?
The bears win.
Yeah. Yeah. So this is actually really important. Remember I made a comment earlier that sometimes people will merge over your changes,
Mm-hmm.
right? What if the code that came in on that specific file was old code and you had already updated it and it force changed it?
Can you say that again? Can you say that again?
All right. So right here, if I go to main here now, right, it changed it. These used to be bears 0 and 17 or something like that, right? But because I merged bears win into main, right, the bears win branch, right, superseded what was on main and overwrote this code, overwrote the previous code, and it just gave me bear Super Bowl chips. That's what happened here.
Gotcha.
And you can tell that's what happened because look at here. It says, hey, we updated this right here. Right?
Gotcha.
Be really, really careful when you're merging. Now, if git checkout, git branch, git checkout, let's try feature fix. And let's switch out of this here. right? Let's say, let's create a new branch. Oh, someone, I think it was someone, Chris, you put C stands for create, by the way. I saw that in the chat. So I'm going to create feature fix 3. So right now they're identical, but here I am going to add test.py. Test. Right. So now my feature fix 3 has some code in it. I'm going to add it. I'm going to commit. Doesn't really matter what the commit message is for now. Cool. All right. So now test feature 3 is different, right, than feature fix. Git checkout feature fix, right? And look at your IDE. It tries to help you out. It says, hey, under feature fix, the test.py file, notice how it's aligned out. It says, hey, this file doesn't exist in this version, right? So if I was trying to merge, git branch, git merge, feature fix 3, if I try to merge that into feature fix, should I get an error? Should it overwrite anything?
Onto me.
What's the only difference between feature fix and feature fix 3?
The new file.
The new file, right? So I am going to merge feature fix 3 that has the new file into feature fix that doesn't. Should I get any kind of overwriting or error messages?
Oh, no.
No, why?
It just creates
it's
a new
not-
file.
Yeah, it just creates a new file. There is no conflicting files, right? Or lines of code, right? So when I merge it, I shouldn't get any kind of error, right? And notice, hey, we just added this one change, right? And it actually tags it. No merge conflict. We just added something that was not there. The only difference between both of those branches, right? So here we go. Feature fix, right? Now has that specific change, right? Depending on how you merge them, be very, very mindful, right, on what code you're touching. If you have a merge conflict, it will throw an error, right? And you will have to remedy it. My advice to you is remedy locally and then push it up, right? Let's see if we can see this up here. Create a pull request. Sure. Made some changes, right? Create pull request. Commit. What's the only change here?
File.
Yeah, I just added a file with a line of code in it, right? Right? Yes? And what does this tell you?
No merge conflicts?
There's no merge conflicts at all. So can you merge it?
Yes.
Yeah. So your GitHub or your GitLab or your Bitbucket is always going to try to help you out, right? If there's merge conflicts, typically, and I haven't worked with GitHub very much at all, but it'll typically tell you right here, right under it, and say, hey, unable to merge conflicts, and it'll tell you specific commits, right? I know GitLab does this. It'll say, hey, this branch is 4 commits ahead of you, the other one, or 4 commits behind, or something like that, to give you an idea of, hey, we can't merge this because of such and such, right? Make sense? Now, right here on your repos, you're not going to have any kind of protection whatsoever because you're still learning how to do this. But once you get to your job, there's going to be a bunch of protections built in your repos that will protect everyone on your team from you messing, or will protect pretty much everybody, right? Like you won't be able to like force push to main, or if something's not linted properly or doesn't have the proper security protocols, the minute that you push it, they'll scan your code. And if it doesn't meet a certain bar, it'll be kicked back. Does that make sense? Don't think you're going to be able to like delete a repo where all the code is. You're never going to be able to do that. And if you are able to do that, it's nobody's fault. I mean, it's everybody's fault but yours because they allowed a junior to mess up their repo. Make sense? That's literally everybody else's fault but yours. Does that make sense? Okay, so right now it's a little bit of the Wild West because I could fix main and push to it, but normally when you get to the real job, you won't be able to do that. Okay, back to this. Let's just wrap this up. I know this went a little long. Conclusion, these are kind of just the basic commands that you really need to learn. Git init starts the tracking of a specific repo. Git status tells you your staged and unstaged changes. Git add adds a specific file or all files to be staged. Git commit message, I think that's required. I think it's required. Actually, I don't know that. I think it is. I think you have to make a commit message. Someone test that. Try to see if you can push something up without a commit message. I've actually never tried. You might be able to, you might not. I don't know. Git log, it prints the commit history. Git checkout checks out the branch. I think I taught you Git switch creates a new branch with all the changes. Git checkout branch name just switches branches. Git merge. Remember, git merge is just one of the many commands, right? You're merging onto the branch that you're on. You have to remember that. You're merging onto the branch that you're on. So if you're on main, you're branching onto main. Make sense? If you're on feature fix, you're merging onto feature fix, right? And depending on how the repo is laid out, right, you may or may not overwrite or run into merge conflicts, which right now it's actually a good thing for you to work through, right? And if you run into them, please solve them locally. Don't use the GUI. Because again, some of you might end up working for like a bank or like one of the car companies or something, and some of their stuff is like super outdated. Some of them will have nice GUIs, but some of them won't. You'll have to do it all via terminal. Make sense? Yep. These are just literally your starter commands. I think if you come down here and you go to the intermediate cheat sheet, which is, I believe, here, right, you're going to run into a bunch more commands. If you get to that, that's fine. But for right now, the only thing I want you to do is work on Git practice, right? This is going to show you how to upload something to GitHub and play with it, right? Create a new GitHub repo, create a pull request. After you're done with this, definitely go into the advanced intermediate Git, which is at the end of your lesson right here. The challenge that I have for you after you finish this specific lesson, the GitHub practice, is try to run into merge conflicts on purpose and see if you can resolve them locally. Does that make sense? Merge conflict is just when there's two branches or you're trying to merge together, they have different codes, right? And Git doesn't know how to resolve them. So you're gonna have to pull it up locally on your VS Code and say, hey, which piece of code is right? This one should take precedent over this one. Save, push through your remote repo. Make sense? Right now, guys, I can stop sharing right now. Right now, you're dealing with literally one file. Right? Did you notice all the code that I gave you? It's not even real code, right? I just wrote some words in it because the main point of this is really for you to understand Git and GitHub. It's really not about writing any kind of code at all, right? Feel free to write just words as long as you understand what Git and GitHub is and you understand the very basic commands, right? You're always going to be able to look some stuff up, but you're going to be much faster at solving problems, right? If you remember a lot of this stuff. Make sense? Because this is what's going to happen when you're on the job. You're not going to know how to do something, and you're going to be pestering people to come help you. And then finally, someone's going to carve out 20 minutes of the day, jump on a Zoom call with you, try to help you out, right? And they're just going to shout a bunch of CLI commands at you. They're going to copy and paste a button and slack you a bunch of CLI commands, expect you to run them, right? That's how help is going to come in the software development world. Make sense? That's another reason why I tell you stay away from the GUI, because nobody's got time for the GUI. The CLI is so much faster. Make sense? And here's another thing, right? A lot of the times, depending on what you're doing, sometimes you'll have to walk through non-technical people deploying something because they have permissions that you don't, right? So a lot of the times you'll just like, this happens a lot in, actually I'm gonna pause the recording here.
Pretty good.
Pretty good, I think.
Pretty good for what it's worth. Gotcha.
Yeah.
Big,
I
big, go ahead.
Oh no, I was gonna say I did it to the T, and then when I got to the end, it's really where I was going back and forth. Where I put so I modified GitHub, a file on my GitHub, and then it said to try to do a git pull to your name, but I noticed it didn't pull, even though I committed the file on GitHub and made some changes to it. It still wouldn't pull the actual updated changes I made to the file on GitHub, and everything matched up. So I was just going back and forth between what I was doing wrong and why I wasn't pulling from it. But I had put in under the CLI to make sure that the push pull were from that URL that was on the repository.
The first thing that comes
No.
to mind is, was the branch correct?
Yes. Well,
Okay, you shouldn't have had an
yeah.
issue then.
Gotcha. Okay.
Now, what the problem that I see often is people will try to pull and they won't be on the right branch. They'll try to pull from a branch on the remote repo that doesn't exist. It just exists locally, right? And that will happen quite often. And it's just sheer confusion on the user's part, right? You didn't know what branch you were in or what branch you were pulling from. Happens all the time.
Yeah.
Make sure you understand what branch you are on. What other conflicts do we run into? Nothing else?
I had
Go ahead.
I had a very niche issue that I wanted to share. I got stuck a couple times in the terminal where I would type in commands. I don't know if anyone else had this. I would type in command like git log or git branch, and my whole terminal would fill up. And I figured I looked into it. It was called a pager. Like the entire terminal, like all the commands that I were typing in would disappear, and it would just be the two lines for the git branch. Um, and then I had to go find out how to go change my configurations for the pager. Because it wasn't showing git branch inline, or it wasn't showing git log inline. It was opening up the whole terminal, and that kept like kind of breaking my workflow. So I mean, I don't know if that's something I did wrong during install fest, but
No, you didn't do that wrong. That's default behavior based on the terminal that you're using. Everyone here probably should have ran into a version of that. If you're
okay.
getting that weird end line at the end and it's acting weird, that's what it is. Google the pager issue and you should be able to fix it. Just copy paste the error into Google or ChatGPT or something, and it'll give you a command to fix that. It is really
Cool.
annoying, but that's the default behavior.
Okay.
I was going to bring that up and totally forgot until just now. Good stuff. I just wanted to go over just a couple things just to reinforce a couple things that I saw. Can everyone see my screen? So here on my terminal, I am in desktop inside my test folder. Everyone knows you could just press, if you've already set up that shortcut on your VS Code, right? You could just open it with code dot and it opens your specific folder, right? Everyone knows that? You could also drag your folder or any folder into VS Code and it'll open it. You don't necessarily have to open it via the terminal. You could just drag the folder to VS Code and it opens it. Just wanted to show you that. Another thing that I wanted to mention is for those of you that are using Windows, you have to make sure, super important, that when you open a terminal in VS Code, this is for everyone using Windows, that every time you open a terminal on VS Code, this shell right here that you're using is identical to the shell that you open outside of VS Code. If this is a Weasel shell, this should be a Weasel shell. If this is a Bash shell, this should be a Bash shell. If this is a ZSH shell, this should be a ZSH shell. Don't use different shells because that's going to confuse the hell out of you. Does everyone understand that? Should only apply to Windows people. Yes? If one of your shells is messed up and you can't get it to work right, stick with the shell that works. You only need one. Make sense? Stick with the one that works. And if the one that's embedded in VS Code, that's really all you need. Right? You can ultimately open multiple shells, right? Like, did I screw this up? Am I stupid? No, there you go. Well, I might be stupid, but there you go. You can have like multiple shells, right? Like here I have 2. I think you can even do more. There you go. I have 3. Probably don't need more than that. All right. If you press exit, if you type exit, you exit. I don't know. Kind of like clear, only more final. Wanted to show you that. Sorry, I'm pulling up my notes here. Oh, what a mess. Sorry. All right. So I showed the VS Code, the shell thing for everyone using Windows. We went over a couple of Git questions. Everyone should have been able to upload a repo, make changes, and make merges. If you didn't get to adequately fixing the merge conflicts, that's totally fine. But if at this point you can create a repo, you can add to it, you can pull the changes, you can merge non-conflicting branches. If you're there, that's a good spot to be for now. Does that make sense? Yes?
Yes.
Any Git related or GitHub related questions?
What about when you write the wrong comment and you try to correct the last comment?
There is a command which I forget that you can go back and edit the commit. Right? Like for I don't even know. I never do it, so I don't even know what the command is. I just know it exists.
I think I just looked it up. It was revert, I think.
CD demo. So yeah, there's a command for it. Notice how I don't know what the command is, right? And I know many of you thinking, shouldn't you know that? Nah, I don't. I don't use it. And I'll show you what I don't use it right now. So if I go git log here, it shows all of my previous commits, right? And if I go in here and I type in some awesome code, right? And I press clear, I know it's going to track one untracked change, and I'm going to go git add, git commit. Need to fix that. And I put my boss sucks. Hope he gets laid off. Right. Added that awesome. Then I wrote some more code, wrote some more awesome code, and I saved it. And I git add, git commit. And my boss really sucks. I hope he gets laid off twice in 3 months. Awesome. And then I go git log. And this is part of my commit history. And I'm about to push it to my remote repo. I probably should have pushed that up, right? Where other people can see it. Right? And you said, hey, what's the command for just changing commits if you messed up? Typically what you would do, you'd have a lot of commits, right? Because you'd have a lot of save points, right? So typically people would ask you, why is this not acting up? Oh, sorry. All right. And you notice that I have these commits that I don't really like or want to push up, right? These two. You can rebase. Let's say the last 3 commits. Oof. Give me 1 second. I'm so used to
head tilde 3.
Yep.
Just figured that out.
Yep. I had that right. What's wrong? Oh, yeah, it's the opposite. Sorry. That's right. Had 3. Right. This is going to give me the opportunity to go in there and change some of those commits. Slightly more advanced command, but it's just something that you can do. So I'm going to do 3, and 3 says, hey, populate the last 3 commits, and I'm going to go in there and edit them, right? So if I go in there, what do you notice, right? It gives me the option of those 3 commits along with our commit hash, right? And I actually don't like this commit at all. So I'm going to squash it. Oh, sorry. And this commit, obviously, not professional, don't want it, right? So what this tells me is, hey, just keep my top commit, squash the other 2 commits. I'm going to escape, right? And it's going to give me the chance to, hey, edit this commit if I want, right? I'm going to. I'm going to put, fixed. Wait, give me a second. Fixed, bug, Jira, ticket, 34.5. Cool, right? Then these really unprofessional commits, I'm just going to delete them. Anything that you see with a like pound sign, that means that that's just a comment, right? Then I'm going to go back out. Boom. Notice what you're going to see here, right? It says, hey, you've made these changes. Cool. So then if I go git log, right? What do you notice?
They're gone.
They're gone, right? And I just have this really awesome professional commit that I can push up. So when you're asking, how do you change a commit message? Is there a command for that? Yes, right? But ultimately, I don't find myself ever needing to know it, simply because typically will only be my last commit before I push something up that I worry about to make sure that it's right. And then prior to that, right, because we've all written code before, right? You make a bunch of changes, half of it, well, more than half of it doesn't work. You made a bunch of save points, right? You have a bunch of gibberish in there. You can go in there, squash all those commits, and just have 1 clean commit or 2 clean commits that you can push up, right? Refactored, X file, and finished, X feature, and then you push it up. Make sense?
Mm-hmm.
Could you go in there and change every single one of the commits? Yes, but why? And I crushed everything down to just 1 commit, but if you wanted to break it down into 2 commits, you could.
What's happening to are those saves or the last one you saved so you can delete the other commits? Or I kind of confused, like,
Okay, yeah, I kind of understand what you're saying, Andrew. So what
yeah.
ended up happening, you know how I had 3 commits before? All those get crushed into 1. So all of those changes will now be under this commit hash.
Okay. Okay.
Did everyone understand that? Because that was kind of a little bit complicated. Remember when I had 3 changes saved? I said, scratch all that. I want that just to be 1 save. So I squashed the commits and made it. So now the difference between this commit and this commit is just that 1 commit hash, just 1 big change as opposed to the 3 little ones I had before. And you're thinking, do all those other save points go away forever? Yes, so you have to be careful. But if this is the good code, right, the cleaned up code, then it doesn't matter. Because that's all I really want. Right? No one needs to know that it took you 15 commits to get the fix, right? No one needs to know that. They just need to know that you got it right. Make sense? Also, if everyone doesn't squash their commits, this is slightly more advanced, but that's fine. You're going to run into it at some point, right? When you go into your GitHub, right? And this is part of the reason why if you go to a really big team or a really big company, let's see, repositories. Let's go demo. You go commits here. Here, there's only a couple commits, right? Imagine you have 10 people working on a project. And each of those 10 people, every time they push something, they don't squash their commits. So they have like 20 commits before a feature is finished. with a team of 10 people. You're going to have hundreds and eventually thousands of commits to cipher through. That's annoying, right? But if you say, X feature was added here, right? Bug fix here, new drop-down menu here, API fix here, right? And all the comments are well thought out. They're descriptive, right? It's much easier to navigate the code base. Because sometimes you have things that are really stupid, like hotfix attempt 5, hotfix attempt 6, hotfix attempt 7 until you get it. They don't need to know it took 12 times. I know you might not understand or you might be laughing at that statement, but that happens. And nobody needs to see that. It kind of clutters the history, right?
Can you go over the squashing again?
Yeah. So here, it's not something you necessarily need to know right now, but knowing that it's possible is important. So here I just made one commit, right? Like if I was to let's say I just, wrote whatever, right? That's just one more commit. Git commit fixed bug. Sure, right? And then I add need to fix that. All right. And then I do git log. I have one more commit, right? This says fixed bug. Right?
Yep.
Yeah.
Yep.
But but all the code was mostly here. Right? This one is like maybe a typo or something or some weird edge case you didn't see. So you had to add another commit. Right? But that's just one more commit that people don't need to see. So sometimes they'll ask you to squash them. Right? So here I want to go back, right? And I want to fix the last two commits because I really just want it to be one. So instead of 3, I do 2, right? And notice the top one, it says fix, fix bug, and I can actually go in there and fix it now, that typo, right? And I really just want to keep the top commit. This extra commit, I don't really need it. S is for squash. And right now I'm using Vim. And then I just want to keep this one. Notice that there isn't like a pound sign next to it, a sharp sign. So here, that's the one I want to keep. This one I want to delete. So here, this comment you can keep or delete, doesn't matter. I always get in a habit of deleting it, right? So I only keep that comment, right? And there you go. I've successfully squashed it. So then when I go to git log, right, it only has one.
I saw Justin's comment in the chat about rebasing. If you rebase commits that are already pushed to a shared branch, everyone else's history becomes incompatible. So just to make sure I'm understanding correctly,
Say that again.
he said Warno on rebasing, it changes the commit IDs. So if you rebase commits that are already pushed to a shared branch, everyone else's history becomes incompatible. But what you're saying is it's a good way to clean up your code before you're pushing to a shared branch.
Yes.
Okay.
I'm showing you this, right? Because sometimes, depending on where you go, they'll ask it to be done this way. But people will just do this locally, right? Because people don't need to see your 15 commits. They just need to see your one commit where the feature was fixed.
Okay.
Make sense?
Yeah.
And typically, right, if you are on a good team, let's say you push something up that's not quite right. It's like 98% of the way there, but there's some edge case you didn't think of, right? Typically, people will catch it before it goes into production, most likely, right? So you can go in there and adjust any of the commits or any of the history before ever it makes it to prod. So it's not that big of a deal.
Okay.
Yeah. And depending on, again, I said that earlier, I mentioned that there'll be like rules on the repo, right? There'll be certain actions that will be blocked for you, right? Like if I try to change main and push force to it, that's going to be blocked, right? Or if I try to merge without certain amount of approvals, it won't let you, right? some of the stuff's really built into GitLab. Like if there's any kind of merge conflicts, it will block the merge. Even if you tried it, it wouldn't let you. Right. So there's a lot of like safeties in place. If you go to a really good company, there'll be a lot of safeties in place that won't allow you to screw up no matter how much you try. But if you're on a really small team, startup, bootstrapping it, you won't have a lot of those, high speed tools probably. Because all those tools cost money, right?
Yeah.
It costs time.
Yep. Alrighty. Cool. That's really all I had for you. Let me just briefly look at the next lesson here. The next lesson is going to be GitHub fundamentals and more GitHub practice. Cool. Last thing that I'll leave you with is if you did not finish the GitHub practice or get to the intermediate stuff, I highly encourage you to get to the intermediate stuff at least tomorrow if you have time. That stuff, like I brought in a bunch of stuff that you it may be in the intermediate part. I don't know. I haven't really looked at it, right? But it's something that you're going to run into on the job, right? I showed you how to squash. You may need to squash when you go to your team, depending on what kind of team you go to. I showed you that Git switch C, which does more or less the same thing as a branch. I think it's just faster, especially when you make a lot of changes that you want to bring to a different branch, just stuff like that. But there's even more advanced commands like cherry picking certain commits and bringing them onto a different branch that I didn't show you because you don't really need to know it right now. But the well gets really deep with Git. But as long as you have a functional understanding of it, I think you should be fine for right now. Does that make sense?
Yep.
This is the one thing they will not teach you at work. Once you get to your job, I have never heard of anyone teaching Git when they give you a demo. They just assume that you are going to know it. Keep that in mind. Make sense?
Yep.
All right, dudes. That's all I have for you. Have a wonderful day. See you guys Thursday.
Night.